Can you hear me now? Okay. Jeez. All right. I'm Martin, and I'm coming from Singapore, and I'm one of the GDEs there. Oh, no, not this one. Excuse me. There we go. Okay. So a little bit about me. I'm a GDE for machine learning and AI since 2017, and back like way before COVID. I came to Bangkok, I did like a PyCon, so I've talked here a little bit. I'm mainly interested in deep learning and research and development, and particularly language and dialogue systems. And of course, the world with ChatGPT is moved in my direction. Okay. So along with Sam, who will talk later, I'm a meetup co-organizer for this Machine Learning Singapore, which is my t-shirt. Machine Learning Singapore, and it's also we have quite a number of people joined our group. There are over 6,000 people in Singapore, which is quite a lot of people for a small country. Right. That's great. Okay, so I also am part of a small company called Red Dragon AI, along with Sam as well, and we're a Google partner. We do consulting and education and prototyping. We also do research, and so we've had papers at NeurIPS and EMNLP, and next week we've got ICML as well. So, anyway. Okay, so I'm going to talk about PaliGemma with some demos, and Gemini-Flash with some demos, and then talk about the cost of either the local model or the API version. So how many people would like a local model? Okay, how many people like an API? Okay, there we go. All right, let me just. Okay, so Gemma, and I think someone mentioned this before. Can you make it a bit less loud? I'm getting. Okay, Gemma is a family of open models from Google. It's built using the same stuff that they used to build Gemini, but basically they want to have a model which everyone can use and is kind of safe. Along with this, it's just very amplified. Okay. Along with this, they've also got CodeGemma for code, and also Recurrent Gemma, which is basically a large language model, but instead of using a long context, it goes along step by step in a recurrent way. Basically, this will allow you to have infinite context, but obviously at the expense of not being like as accurate over the fixed context. The last one announced was PaliGemma, which is what I'm going to talk about today. And the nice thing about this is it's an Apache 2 licensed model. The Gemma 2 is now released, so this was coming soon, back when I first talked about this in Singapore. Okay, so PaliGemma. So the first thing to see is there's a demo on Hugging Face. And so if we go on to some sample images, here's the demo on Hugging Face. They have set up a Hugging Face spaces, and I can now drag and drop images in here to PaliGemma, and then I can say caption. So PaliGemma has been trained to do a few tasks, and you can also ask questions as well. But one of the special tasks it can do is caption. It can also do segment and detect. Okay? So if I ask it, well, what is happening? Caption this. It says 2 men in suits shake hands in front of flags. Okay, it is right. But it might know more, the man. Okay, so basically it's got a limited length, which it will produce. It's producing these tokens one by one by looking at the image. So you can see that it is doing something. Let's describe kind of what's going on, and then I'll show you the code. Google Slides. Okay, so the Hugging Face demo, anyone can go and just plug some stuff in. So the architecture of this is basically in the middle here. We have, actually this is a diagram from like a year ago. So this is the same architecture which was used in a thing called Mini GPT-4. So basically, the architecture hasn't changed. This is not a new thing. Basically, the Vicuna model, this is a year ago, is a large language model based upon llama. And into that, we're going to put an image. Here's an image of a flamingo logo. We're going to use a VIT model and then put it into this large language model. So we're going to treat the image as tokens, as if it was text. And then you can then ask the Vicuna model or the PaliGemma model, tell me about this logo or whatever. So the difference that PaliGemma has is instead of this Q-former VIT, they're using a thing called siglip. And instead of Vicuna, they're using Gemma 2B. So the Gemma 2B is just a regular Gemma model, and they're using their own image translator to put the tokens into it. So the vision component, actually this is just the same as clip, really. This siglip is basically clip. This is a diagram of how clip works. Basically what you do to train this vision component is you give it text and you give it images, and then you say this text, so my thumb should match my thumb, and my little finger should match my little finger, but this finger should not match my thumb, right? So basically I now have a matrix which should be 1 down the middle and then 0 everywhere else. So this allows me to train text to images, or text and images together. So the benefit of doing this is afterwards I can throw away the text piece. All I want to do is train my image model to give me good representations. Okay. So once I have my good representations, I can put it into my language model. So the language component here, instead of Vicuna, this is the Gemma 2B, has got lots of little tweaks. So Google has looked at the other models and just tweaked a lot of different things. So there's some there are strange choices here which work well, but there is no research paper. So we don't know why it works, really, because this probably means there are lots of other experiments which they tried, but they only show us one. So we know that there's good data here, but they didn't tell us, right? There's lots of failed models to choose this one. Okay, the other thing which we need to do is go from the vision model to the language model. And what we need to do is convert the vision representation, the image, into text. And so what we have here, and what we had before, let me just go back, we've got this linear layer here. And this is a simple thing which changes from what I get from my vision model into tokens. So how does this work? Basically, we have, for a whole image, we convert it into little patches. And each patch is 14 by 14 pixels. And that's going to be one token. But the tokens, the dimensions we're getting from our vision model are 1152. But Gemma 2B is 2048. So we have a thing which just multiplies the 1152 to make a 2048. And we can then train this by having some pictures on our pre-trained vision thing, having some questions, and then forcing the answer with not even changing the Gemma, we just force the vision to line up. So what we can also do is we can have different resolutions for our picture. So if I want to put in a 224 by 224 image, I'm going to get 256 tokens. If I go up to an 896 by 896, I'm going to get 4,000 tokens. So all we do to make the images bigger or smaller is use a model which will take these larger contexts. But you can also see that 256 is much smaller than 4,000. Right? So doing a 4,000 token image, as it were, would take a lot longer to process than the 256. Okay, so I've got a little demo of the thing. There's also a QR code for this. Sorry, I'll leave it there for the moment. QR code. And what this will do is this takes you to a presentation which I gave in Singapore, and that also has a link to the collab. So in the collab, what have we got? Here we have a collab notebook. Let me supersize this. And basically, I'm going to use Hugging Face transformers. So I'm going to do the whole thing which I did but on the Hugging Face thing, but in code here. How many people know Python? Python? Quite a few. Okay. So hopefully this is interesting to you. So what I do is I pull in the transformers and the PaliGemma model, and I pull in the PIL library for images. Then I check that I've got a CUDA device. Here I'm just using straightforward ordinary Colab, free Colab. So I've got a T4 GPU. I'm going to ask for the 224 sized model. And then I just load in the model, and then it goes and downloads like 5 gigabytes of model. And then I can I can have a look at what it is using in the memory. In here, it doesn't seem to have taken up the memory yet, okay, because I haven't used it. Let's try an image. So I've got my image of the Xi and Biden here. So I'm pulling in the image, and I make a little function to make the image like a nice size. So I can actually just nice size the input image, and here's my picture. Of course, there'll be a much better image today of Trump. It's exciting news about Trump. Anyway, Xi and Biden will do us for today. So I also have write myself a little function for get answer. So basically, when I give it some text, I will then put the text through a preprocessor to convert it into tokens. I also give it the images to convert those into tokens. So this has now got 2 sets of tokens. And I can then just say, okay, put in all of these images into the model and give me some output. And I then decode that output, which will be text. And so if I say, who are these people? This is what PaliGemma will tell me. So it can actually answer questions. As well as doing caption, it can answer questions from its general knowledge about the world. Okay. If I say caption, okay, it's come up with a different answer from Hugging Face. So there's no guarantee that the answers will be the same every time. Just slightly different settings will cause it to, if it makes a slightly different first token, the second token will be different. The answers will diverge very quickly. In this image, we can see 2 persons standing in front. In the background, we see flags and a wall. Okay. All right. So what we can then do, okay, let's have a look at, so I've said we can answer questions, and we can say caption, but we can also say detect. So if I say detect person, it will then try and put bounding boxes around person. Okay? And so if I do, here it says it's got a person with this lock, and here's another person with lock. Okay? So the question is, or we can say detect Xi Jinping. Okay, so here now we have another lock. Okay, so the question is, well, what do the lock tokens mean? It's been told output some stuff. Basically, I can essentially translate these directly into a location to give a bounding box. So these are just giving me the different corners of the box, which I can then scale and make a bounding box. So here I put in a comment some of the outputs which it gives. Basically, once I draw a nice sized bounding box, it will draw a bounding box around the person. So this is quite nice for a free 3 gigabyte or 3 gigaparameter model. It can do quite a lot of things. Okay, another trick we can do is called segment or segment. So we can say segment Biden, and okay, the problem for us is when it gives segment Biden, it gives lock, and then seg, 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 seg. So the question is, what is it doing? What are these seg tokens doing for us? So what we can do is we can actually go and have a look at, because all the code is open source, we can look at the code. Okay? So if I have a look and see what it's doing here to look at the objects, here is basically it's extracting the seg tokens. But if we look up here, which is the decoder, the interesting thing here is it's got a little convolutional neural network. So what they do here is these seg tokens don't tell you the points. They're the thing which needs to be passed to a little neural network, which will then tell you, draw a nice outline. So if we go back to the Hugging Face thing and do segment detect, and I think I'm going to have to let's drag she along to here, pop him in here, cross fingers. About black blocks, no, don't do that. Try again. Here we go. Oh, come on, you can't block me now. It worked just next door. Let's try one more time. This one, I should be able to. Can I copy and paste it? Can I paste? No, I can't paste. Well, thank you. The third one? And paste from clipboard. Here we go. Okay, something happened. So if we do entities to segment detect, we do segment widen. Okay, so Hugging Face, there's a queue here, so it's going to count down. So normally the PaliGemma model will, ooh, okay, oh, it's tried. So hopefully, come on. There we go. Okay, so it seems to be a bit offset, but there we go. It's got a bit of a Biden. So here it's translated the seg, 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 seg into this map, probably between the coordinates for the lock, which it gave me. Right? Okay. Oh, no, Google. Of all the time you think. Anyway, okay, this is partly because I'm using a free instance, right? So free Colab will disconnect. Paying for Colab, they will keep you connected. All right, so we can see that the PaliGemma can do this segmentation. Another thing we can do is, suppose I have a receipt, like this Walmart receipt. I can say, how much did the mouthwash cost? Okay, if we look on here, there is mouthwash, and it should cost me $3.37. Unfortunately, it says it costs $2.38. Right? So it's read the wrong one, but it's trying, okay? It's not very convincing, but it's trying. Another thing we can do is I can do OCR receipt. So basically, this is another of these special commands, and here it's produced me a whole bunch of different things. And it's not actually a very good OCR if you compare them, but it wants to try. It might lie to you, but it wants to try. Okay, so let's just talk a little bit more about what's going on. So there are kind of extra things about PaliGemma, which are cool. They've provided lots of different checkpoints, so one of which will be fine-tuned for, I don't know, self-driving, something will be tuned for another task, or tuned for people or something. They've produced these checkpoints, all available to download. They've produced versions in JAX and PyTorch, and there's also a thing about Keras loading. So this is new. If I go to here, this is one of the other GDEs on the team Keras. Basically, they've made it so that you can actually use Keras, the latest version, and the latest version of Keras does TensorFlow and JAX and PyTorch backends. You can then use their NLP models and then just load in one of these Hugging Face models. So now Keras can use all of these Gemma models all seamlessly. So this is pretty neat. Okay, this thing obviously works in Colab 4, and the thing which came out just last week is a whole technical report about what they did, how they trained it. Quite a lot of good technical details in this tech report. If you're interested, have a look at that. Particularly if you're using this model, you should have a look at that. Okay. On the other hand, it is a fairly small model. So you saw the OCR, it got the answer wrong. If you ask it really complicated questions, it will get the answers wrong. So the next thing I will talk about is Gemini-Flash. So I think we'll hear a lot about Gemini. I like the Gemini-Flash model because it's twice as fast and 10 times cheaper than the real Gemma model. Right? So this is, in some ways, if you think of Anthropic with the Sonnet model, with the Haiku as the cheap version. Here we've got Gemini Pro, and then the Flash is the cheap one. And it's not much worse. It's like twice as fast, 10 times cheaper, much better. You can also do 1 million tokens context, which is a lot, maybe 2 coming. So it can handle text and images and video and audio. And here we're just interested in the vision bit. This is these are the slides which are shown on the. You can see this is the little person for the real Google I/O. Basically, it's meant to be fast, cost efficient, and it can do this whole kind of multimodal reasoning. And in research, I've now switched from the Pro to the Flash model because it's a big model, but it's capable, but it's so much cheaper. It makes a huge difference. Okay, so this is a kind of analysis from a website called Artificial Analysis. Basically, this is looking at the cost of GPT-4 Turbo and the capabilities. So the GPT-4o kind of beats it because it's cheaper and slightly better. And then there's a whole slew over here of different models. And Claude Haiku is currently on kind of this efficient frontier. Now, Llama 3 70B is pretty good too, slightly better, slightly more expensive, but it's the API, then you'd have to set it up and do these things. And we'll talk about costs in a little bit. Okay, I can do a Gemini-Flash demo. Let me just go on to there. Okay, so here we have, I thought this is AI Studio. Hopefully everyone has seen AI Studio. Okay. So I can put in easily copy the picture of Biden and Xi, and then I can ask, who is in this image? What are they doing? Please provide a bounding box for their handshake. Right? So I can give it a whole bunch of instructions. So one image, a complicated prompt. The PaliGemma wouldn't be able to do this. The PaliGemma is more like one image, one question, one answer. Okay, so it says the image shows, hopefully you can see, Xi Jinping and Joe Biden shaking hands. The bounding box for the handshake is these numbers. So how do I write the code? I just say, just write the code, right? For all of these things, the old way of coding is gone, right? Basically, if I have a question about how it works, I should just ask the model. I can then say, so it then produces code very similar to what I have in my Colab, but it didn't work, right? And the reason it didn't work is, just a minute, what is the format of bounding boxes you're returning? So then it tells me, okay? Then I say, just a minute, pretty sure you're giving me the coordinates. So it got them the wrong way round. It's kind of lying about what it's doing. But then you just say, redo it, give me the proper answer. And then it's, you're absolutely right. My apologies. It's like, just should answer right the first time. Anyway, so now it can do the right code, and I can adjust my code to fix it up. Okay, so this is pretty nice. even though the code bit is not perfect, it's trying, but also the bounding boxes were accurate. The code it gave me just wasn't right. Now it's fixed. Okay, so the next question is, okay, I forget that. What else can we do? Suppose I go for the Walmart receipt. Okay, so how much did the mouthwash cost? It's made a different kind of mistake here. So it didn't lie to me. It just says the receipt does not provide a price for the mouthwash. And it does. It really does. Then we have a list of all the items with serial numbers and prices. Okay. Oh, it does know the mouthwash exists, right? So it's just had a bit of a disconnect here. So the mouthwash cost how much? It doesn't list the price for mouthwash. So is this a complete receipt? It seems like this is only a partial receipt. It says continued on the back, which it does. So there's more information on the back. If you want to know the price of the mouthwash, you need to check the back, right? Okay. So it's really trying. I mean, it does. If I wanted OCR, it can do an actually great job. And then let's see what else we might do if we had good OCR. So it wasn't this one, financials. Is it this? Okay. So here I have a picture of a PDF. So this is I'm not sure I can pull it up. Basically, this is not a simple PDF. It's from a financial report. It's got columns. It's got text. It's got, maybe I can actually give you. Do I have a picture here? There? No, it's not. Okay. All right, so this is a PDF which is not so simple. Basically, I can ask, please render the contents of the table in Markdown, paying particular attention to the columns, blah, blah, blah. And then its response can be just like perfect. So this Gemini-Flash is pretty good. You can then ask questions about, like, do some reasoning about this thing. These things are very, very effective. I can also say, give me bounding boxes for all the entries. Suppose I wanted to do more sophisticated, analysis of the hierarchy or something. So I'm also interested in, can I keep the cost down? So if I give it I don't want to ask one question, then give it the whole image, and then ask another question, and give it the whole image and ask another one. I would either want to ask lots of questions for one image, or use the new caching thing which they're coming up with. So what I was interested in doing is, suppose I were to essentially take their markdown here, I can then export that easily to, here it is in Visual Studio. Okay? So this is just the text, and I can then, using Visual Studio, just look at the markdown, and it's extracted all this stuff. This is kind of beautiful. Okay. All right, so let's have here's the other things it's asking. And you can kind of see the count of the tokens. So to get out the tokens from that PDF image, this is using about 2,000 tokens of the million token possibilities, right? 2,000 tokens is 1,000th of a million tokens. And so you can start, when we see the pricing of this, you'll start to see how that this is extremely cheap. So the pricing here is, they're charging 0.000375 per 1,000 characters. So in order to do 1,000 financial tables into nice, spreadsheet format, it's going to cost $12. Now this is actually pretty cheap compared to lots of other OCR methods. Just getting Gemini-Flash to give you the answer just by asking it is actually super cheap. And from what I've seen from some startups I've talked to, they are like replacing their existing OCR with Gemini-Flash, just because it's so much cheaper and more accurate. Okay, so in terms of, so that's a quick demo of what Gemini-Flash can do. Hopefully, there's a lot more it can do, but that was just the vision kind of thing. But it can also not only just answer questions, but it can do bounding boxes. I haven't tried segmentation. Maybe I'd have to agree with how to do segmentation with it. Bounding boxes is kind of easy. In terms of cost, so the PaliGemma, I can run that on a T4 machine on GCP. So a T4 GPU costs 35 cents an hour, which is this one. And then I'd have to put it inside a machine. So just a normal machine would cost about 25 cents an hour. So all in, we've got 60 cents an hour. So this is, it's actually surprisingly cheap compared to buying your own GPU. But how many could I could probably do an image every 3 seconds or something. So we're talking about 1,000 images for 60 cents in some ways. So this is kind of, we know that the quality isn't great, but the price is cheap. On the other hand, for Gemini-Flash, which exists, so we don't have to launch any hardware. If we don't like the model, we can choose another model. There's a lot of nice features of not having to run this locally. We know that based upon the pricing of these characters or tokens, we can get 1,000 formatted financial tables for $12 or for $12. And so there is obviously the Gemini, the PaliGemma's cheaper, but in terms of labor cost, and is not so clear. If 1,000 documents cost me $1,000, then it's clear I should try with the PaliGemma. But if my difference for 1,000 documents is now $12, it's not so clear that I don't just, from an engineering perspective, don't just move over to Google. On the other, I'm totally happy with the local models. So for my research, I use two kinds of models, one of which is the open source models, which I can run, because I can be absolutely sure the model is exactly what I think it is. But for the API models, I can't be sure that it's not. I could try and pin the version, but I can't be sure they're not changing the model. I don't know what data it's been trained on. It may give me good results, but who knows, in a year's time, that model may not exist anymore. So from a research point of view, these big API models are not very good because your research will never last. Whereas I know that in 10 years, someone would be able to use the same version of Gemma as I did and get the same results and use my code or whatever. So there's a good philosophical difference here. One of the other nice things that Google is doing with these Gemini models is they're making sure that the data stays in the country that you know where the data is. So that's useful. In Singapore, we need any personal data has to be stored in Singapore. I guess the same would go for other places. And so this is kind of a nice thing, whereas Californian companies are not necessarily so careful with where your data's going. Or maybe Chinese companies would not be so careful. Google is paying attention. Anyway, of course, if you're using a local model, you know it doesn't even go outside your room, so that's also good. Okay, as a wrap-up, so PaliGemma is open source. This is thank you very much to Google. The Gemini-Flash is much more capable. And maybe the cost is more, but the convenience is a huge factor. Maybe what you might do if you're making a product is to use Gemini-Flash to do all of your prototyping and then initial customers. But when you go for real scale, maybe you want to use your own model. But what you should do is every interaction you have with these API models, you should record everything you say and everything that comes back, because that can be training data later. So you don't want to prototype everything, get it working, and then have to collect training data. Better to collect everything you might need so you can train it for when you go for scale. That may be a nice idea. Now, Google has Google doesn't really want you to train models on their outputs, but I'm pretty sure that people will be doing that. So just, there we go. All right, I will wrap up there. Thank you very much. Sorry? Okay. Any questions? Okay. Oh, you have questions.
โอเคครับก็เดี๋ยวจะมีการตอบคำถามโดยคุณแอนดรูนิดนึงนะครับก็สำหรับคนที่ถามคำถามเข้ามา
Oh, so this is some. So shall I talk about this one now? Or
Yeah, okay, you can do it now.
why? What do you want? So, what is the alternative?
You can do it now.
Okay, I'll talk it now. Okay. All right. So someone is asking, do you think AI developers should have a basic knowledge of machine learning? I think I'm biased. I think probably yes. But one reason is not because I want people to know mathematics or I want it to be harder. It's just that if you don't know some things about machine learning, you may make errors which you don't know you're making, right? So if you've got, for instance, machine learning people will say you need a training set and a validation set and a test set. If you just say, well, it works for me, let me lose some of my customers, you've missed a big step about how do you know whether the model is when it's wrong. There's a whole lot of how do I test the model, how do I probe it, how do I evaluate it, that machine learning would tell you you have to do. Just saying, I call the model and it gives a great answer. Okay, now I have a product. There's quite a lot of, there are steps which are missing. So some of the machine learning foundations are kind of useful. So you don't have to know the mathematics of it. I think it's nice to see the mathematics. So you can see that all these models are doing is multiplying numbers together. There's no magic AI. It's just here are some text, here are some tokens, here's some multiplications, and we get tokens answers. It's incredible that this works, but it's just training them. It's just lots of numbers which get trained. It's not a big database. It's not, intelligence like in our heads. It's just numbers, very, very big models. So just some small amount of knowledge would help a lot. Okay. Can we fine-tune PaliGemma? Absolutely. So they have provided fine-tuned checkpoints as good starting places, but they've also provided raw checkpoints if you want to really fine-tune it yourself. They're super open, and there's also guidelines about how to do it. So, next one. PaliGemma, definitely you can run this locally. It runs on an 8 gig machine just fine. Okay. I'm not so sure about the smaller models for mobile. So next week, I'm giving a talk about smaller models. The problem is that Google would say that a 3 billion parameter model is a small model. So pretty soon, it's going to be in your Chrome, right, or one of these small models is going to be in your Chrome. I'm not sure it's going to be a vision model, but people are really working at this. So another place which is doing the small models is Facebook. And so there's a meta thing about mobile language models. And so they're working really hard. So Facebook have these nice llama models, but they're also going smaller because they care about the phone. So if you haven't already used it, in your WhatsApp, there's the 70B model, and some people have now got the 400B llama model running for free in your WhatsApp. Okay. Okay. I haven't integrated PaliGemma into an agentic workflow already. I'm sure people are doing this. It's a nice model. It's like the Google models are good models, that they're kind of workhorse models, but they're not fancy models, I would say. There are data sets now of using these kind of for apps, for mobile things. People are, the data's the amount of data for agentic stuff is rising, so that's good. Pixel attack. Okay, this is a good question. One issue with the these CNN-based models, you might get these issues with fake images which are on a panda which it says is a parrot or something. And this kind of used to be a big thing, I guess 4 years ago. People are worried about these fake images. With the VIT models, I think it's less likely to occur, but I'm sure it can be done. So I haven't seen it, but my guess is it could be a problem, but probably not as radically as the CNNs. Few-shot learning. So in my research, I use few-shot learning, but I'd also say many-shot learning is also interesting. So for one, I've got 20 examples followed by a question. Another one, I have 6 harder examples with a question. But there's a DeepMind paper which is using 1,000 examples followed by the question. So when you have a 1 million token context, you might say, I will never train my model, I will just using context learning. And so few-shot is great. On the other hand, once you've done that for a bunch of things, you record everything you said and everything you hear back. I will then use that as a training set for one, so I can ask one question, one answer, to make it a 0-shot after fine-tuning. Okay. Oh, I see, now you've got a remote. I'm not sure about Ollama. So I'm not sure whether PaliGemma is an Ollama. No, I don't think so. I like Ollama as a local model thing because it's super convenient. And I don't think you get many times better. So I use Ollama locally. PyTorch is nice, but at the moment, since I like these kind of few-shot examples, I'm using mostly Ollama. PyTorch is nice. Instead of raw PyTorch, there's a nice library, which has slipped my tip from tongue. Sam, what were we using for the training? Unsloth. So Unsloth is nice for training. So it is kind of a PyTorch, but it's covered in Hugging Face and various other things. Basically, it's all kind of black box recipes at this point because we can't really deal with the insides of a model too easily these days. So I can't. So I don't understand why it's giving the wrong price result. It may be horizontally, it's just saying it should have lined up. Maybe the receipt was a little tilted. It may be that it can't be hallucinating a lot, but there were other mistakes as well. For instance, some of the words it did OCR, it actually has different spelling of the words. So it may be doing some kind of correcting between what goes in and what comes out. So it's definitely not perfect. Whereas the Gemini-Flash, I would think that they really care about OCR. So much more likely to be right.
Okay, all right. Please thank you to the Mr. Martin Andrew ขอตบมือไปให้กับคุณมาร์ตินอีกรอบนึงนะครับครับก็ได้เห็นการเดโมเกี่ยวกับ Gemini ตัวโมเดลแบบไลท์เวทไปแล้วนะครับเป็น Gemini-Flash นะครับก็เห็นได้ว่ามี potential อะไรหลายๆอย่างเลยแล้วก็มีในส่วนของคอสก็ค่อนข้างจะต่ำกว่าเยอะเลยก็สามารถลองไปปรับใช้กันดูได้นะครับเผื่อแบบใครที่ใช้เยอะๆแล้วแบบโทเค็นมันระเบิดเนี่ยครับก็ลองมาเปลี่ยนมาใช้เป็นโมเดลตัวเล็กดูได้นะครับ